We're gonna wait like 2, 3 minutes to leave some time for people to trickle in and then get started.
And in the meantime, if you're not on the Meet Echo, then please scan the QR code.
Yeah, do we have volunteers to take minutes and or Jabberscribe? Thank you, Stuart. Much appreciated. Can anyone be the Jabberscribe? It just means watching on the scribe, and if someone says make colon, you relay what they say at the microphone. We'll smile at you to thank you. You won't see it through the mask, but I promise I will. That, I can do that. It's a very low effort role these days. And can we have a backup to take notes from what Stuart is saying when Stuart goes up to the microphone? Who would be willing to do that? It's a collaborative tool, so you could just add edits and it works really well. It's funny. I've never seen everyone look at their email so intently than when I'm looking for a minute taker. Yeah, well, let's look at the remote people too. See who's in there. Yeah. Yeah. Thank you so much. Most centerpiece of the thing is bottle of the thing of Lysol. Yeah, very probably clear this one. Yeah, looks pretty good actually. Yeah, yeah. Hand it to me. I can put it over on that chair. What's going on, Stuart? All right. Yeah, sorry, we forgot to copy the agenda in there. Our bad. Um, should we get started?
Yes.
All right. Hello, everyone, and happy Thursday. My name is David Skenazy, and this is Chris Bucks, and we are here to talk about DNS service discovery. Um, this is the Note Well. Note it well. This is Thursday, so most of you probably have seen it before, but in case this is your first meeting, we want to insist on it a little bit. Whether you're registered in person or remotely, you agreed to this note well. And if you haven't read it before, don't try to read it off the slide. The font's way too small, but it really matters into what we do. So for example, when you say something or type it in the chat or on email, it triggers some requirements with regard to intellectual property. And it also says that you agree to follow our code of conduct. Luckily, that we haven't had issues in this working group, but I just want to talk about it to guarantee that we keep it that way. All right, next slide, please. Also a reminder for folks who are in the room, at this IETF, masks are required, and you have to wear one of those fancy certified ones. If you only have a cloth or another one, we have free ones by the IETF registration. And the only exception is if you are actively speaking up here at the chair desk or at the front under the anvil there, because because we're far from the rest of the room. Next slide. So thanks, Stuart and Dave, for taking minutes. And who's doing Jabber Relay again? Oh, I am, right. I'm sorry, I'm very tired. It is Thursday. Next slide, please. All right, here are some useful links if you're seeing the PDF on there. Don't try to click that screen. Next. Similarly, we have a GitHub organization. Ted, we should sit down virtually at some point to get everything on GitHub on there. That'd be nice. But maybe not for the ones that we're about to send to the ISG because they're almost done. But for the new adopted work, I think that would be nice. Cool. Next slide. So an update on our currently adopted working group documents. So the SRP draft has been in working group last call for a year to the day, actually. And those comments were addressed 2 weeks ago. So we're going to chat a bit about that and hopefully start a second working group last call and send it to the ISG in the near future. The update lease document was adopted a little under a year ago. The comments during adoption were addressed. That's not a whole lot of revisions, but it's a pretty short and simple document, so we expect it to be ready to progress as well. And we'll talk about that a bit. And of course, if anyone has objections, we'll give you an opportunity to say so. And the advertising proxy document was adopted last August, and some comments were addressed, and that one still needs more work, so we'll discuss it in the working group. All right, next slide. And then we have some individual drafts that were published last year, and some of them were updated right before the draft deadline, so we can talk about those. And one of them is expired. All right. Intentionally. All right, so we can remove it from the list. We can talk about that one later. Our current agenda is kind of going through these drafts in order. I realized that we kind of tweaked the agenda a little bit talking with Ted, and we forgot to update this slide. But talking through the working group drafts, their status, then through the ones that Ted would like to see adopted in the nearish future, and then some open discussion time. So would you like to bash the agenda that is not on this slide? Are we missing something?
So I had suggested that maybe we want to talk about Unicast's Dnssd, but if time allows, but I don't know if that needs to be explicitly on the agenda.
Yeah, that sounds great.
It is on the agenda that is listed on Data Tracker.
Gotcha.
So we do plan to cover it. Yes.
Sweet.
Cool. Next slide, please. Oh, right. Yes. And I forgot to mention in the agenda that we had a little presentation from our area director, Eric, about a newly formed DNS directorate. Tell us more about that, Eric.
Well, actually soon to be formed. So next slide, very quick. So Tim Winczynski, you mostly know him, the chair of dprive and DNS Hub. Let's make some stats by looking by the word DNS in the file name for the internet draft, as well as in the abstract. About 59 was catch since April, including 3, no surprise, from this working group, but as well from others. So next. These are basically non-working group documents, right? So not yet adopted. And in some case, it has nothing to do, if you look about the potential working group name, it has nothing to do with DNS Hubs, dprive ADD, or Dnssd. So we may assume that the knowledge, the DNS knowledge of the people in those working group is not as high as in this room or other room like DNS Hub. So the fear of the IAG, and we have seen as we receive document that has gone through working group last call, working group last IETF last call, arrive at the ISG, and then we spot some DNS issue. It's a little bit late in the process. So what we want to do is recreate a DNS directorate so that any working group, based on the chairs of those working group, can request an early review by the DNS directorate. So next slide. So we got a meeting with ADD, DNS Hub, Dnssd, and dprive chairs, plus the ISG, and a couple of, we get 2 meetings actually, to create this DNS directorate next week or in a couple of weeks. We will be sending an email to the community, including this working group, asking for volunteers to be reviewers, early reviewers. Of course, you will not review all documents coming out from any working group, only the one those working group think there is a DNS there, a fully qualified domain name, a .local, a .arpa, or some reliance on DNS. And like in all directorate, there will be reviewers. We are looking not only for expert, and I'm looking about the two Dnssd, MDNS expert there to be at least one of the two, right? Because MDNS is special really. But also in operation, in privacy and so on, as well as junior people, right? The IAG really wants to get a pipeline of talent. So one way of growing talent is start as a junior reviewer. Perhaps your review won't be the most perfect one, but you will learn how to do it and learn by mistake. You need to learn on the job. So it's open to everyone. Oren Kumari and myself, we will basically select those reviewers, small group normally. And we are also looking for 2 secretaries. So there's the people, they say, oh, we got a request from working group Foo, which is the next reviewer. So there's a kind of a clerk or bookkeeping thing, administrative thing that you do once a week typically, and you select the right reviewer. And that's basically it. I'm unsure whether there are questions, but basically that's a call for volunteer. I will send over and we'll send an email end of August about this after the vacation. Okay, thank you.
Yeah. Thanks, Eric. Does anyone have any questions for Eric? And I want to underscore the point that, like, you don't have to be the person who invented DNS to be on this directorate. Knowing a little bit about it is pretty sufficient, and it's a great way to know how IETF works and to see documents that you might not know. So, if you're interested or have questions, talk to Eric. He's very nice.
He is.
All right. So we're.
Do you want to drive the slides or shall I?
Let's, why don't we try with you and see how it goes? I'm gonna mask because I always have trouble regulating my breath when I'm talking into a mic with a mask on, so I apologize. So first we're going to talk about document updates. Next slide. So the main document that the working group still has outstanding for a long time is the SRP Service Registration Protocol document, and that document was in pretty good shape when we did the last call. We got a couple of additional comments, and I took kind of a long time to get it done. And while I was working on the final update, actually before I did the final update, I updated the TSR document, and I realized that there were some terminology problems with the SRP document. So the first and fairly substantial change to the SRP document is just changing all of the sort of like server, client, service zones, things like that, getting that terminology correct. So SRP clients are now requesters, SRP servers are now registrars, SRP requester, SRP registrar, depending on where you look. And that just reduces the confusion. There are a couple of places where we talk about DNS update clients. Those are still called DNS, or DNS update requesters, I think. And then DNS servers are still called DNS servers. And then I noticed when I was doing the update that the text that describes the discovery of browsing domains was wrong, so I fixed that. That was just me. Nobody commented about that in the last call. Fortunately, we're doing another last call, so if anybody thinks I'm wrong about that, they can correct me. And then there were just a couple of comments from ESCO about suppressing unusable records, which is something that came up when we were talking about the advertising proxy, and also clarifying the service discovery instruction section he found kind of unclear. I thought it was perfectly clear. I wrote it, but he had some suggestions, and hopefully it's clear now. So we still need ESCO to tell me that I actually got it right, and we may do another cycle on that. And the chairs have already decided we need a working group last call. So any questions about SRP? Nobody's coming up to the mic. Next slide.
So hold on, before we move on, just to confirm for everyone, the working group last call has been kind of going on for a while, and a lot of folks have forgotten about it. And I wouldn't blame anyone for not remembering what they said a year ago. It's been a while. So we're going to officially have a second working group last call, the really for real last call. That's going to we're going to start it very soon and last for 2 or 3 weeks. And hopefully if everyone can take a look, especially like these terminology changes, I know every time I do replacements like this, I get one of them wrong. So please take a look. And then assuming that ESCO's okay, because he had some comments before and no one has some serious comments, then we'll send it over to the IESG. And so if anyone has any concerns with this approach, please say so now or during the working group last call. All right, thank you.
Thanks. Now next slide. Oh, yeah, there we go. Yeah, so the other document that's sort of close to or hopefully at time for WGLC is the update lease document. Again, the terminology change is a little bit more restricted here because the update lease document is not actually an SRP document. So we don't talk about SRP requesters, we just talk about DNS requesters, DNS update requesters. The document was, it's been around a long time, and when I was reading the document, and I saw, we did actually get some comments. You guys said there weren't that many comments, but we did get a couple comments, and the comments seemed to largely be a result of failing to understand the behavior that was being described. So I tried to sort of organize things a little bit differently and talk about like the server behavior and the requester behavior for each type of message. The update message and request message are actually the same message, just in a slightly different context. The initial update is obviously the initial one, and then refresh messages come later. So there was also a question about, like, you know, disambiguating whether like the behavior for refresh messages was explained as being different than the behavior for update messages, but that assumes that the server knows that it's a refresh message because there isn't any signal in the message that it's a refresh message. So so there's some text in there that just kind of clarifies that and talks about, like, well, you know, if the server knows it's a refresh message, it should do this, but if it doesn't know, then obviously it can't. It's going to just see it as an update message, and this is what will happen if that's the case. So hopefully that's clear. But you know, if folks see that and it's not clear to them, please obviously bring that up in the last call. And there was also a question on the handling of the key lease interval, and I updated that. Somebody asked whether there should be IANA considerations. Originally, there weren't IANA considerations because the EDNS 0 option has already been registered. However, the registration for the EDNS 0 option is actually not consistent with other EDNS 0 option registrations, and so I added an IANA consideration section that just like fixes those inconsistencies, and also requests that the entry refer to this document and not to draft Sakara update lease. So thanks for the folks that reviewed this, and I claim this is at least ready for a last call, in the sense that, you know, there may still be more things to do, but a last call will hopefully catch them. It's not so immature that that's going to be a problem.
Oh, sorry, we had a meet echo failure right here.
Uh-oh.
Well, while Chris tries to fix that, I think if you start sharing again, it might work. Oh no, or just. Yep. Oh, no, it's working. So, yeah, from the chair's perspective, this draft hasn't gone through many revisions, but we're not, you know, required to go through many revisions if it's something simple. And so we think that a working group last call will be a good way to get people to review and flesh out or hash out any remaining problems. So we're going to have a working group last call that has the same duration as the second one for our SRP or at the same time, because it makes sense to page both of them into memory together. And we ask that folks please take a look. We'll want at least a few reviews before we progress this to make sure that we catch any mistakes. And then we'll progress them to the IESG. And if anyone has any concern with that, please come and speak up now or during the working group last call. That's also a perfectly valid time. All right.
By the way, I just remembered the reason for the key lease documentation update was that somebody asked, like, why do we have a key lease thing and not like just generically for any kind of thing. And that's because this document didn't reference SRP, which is what needs the key lease. So I added that. So just for completion or completeness. Next slide. Okay, so advertising proxy update. This is actually, this document, I think we're converging on where we need to be, but this was a fairly substantial update and reorg. I don't actually remember the details of how it was before, but basically I divided the document into talking about the different functions that the advertising proxy needs to do. I also updated the introduction and the abstract, but this is the main updates were about how it functions. And it's kind of interesting, like the taxonomy that I came up with actually isn't talking just about the advertising proxy. It's talking about all the things that need to be present in a thing that acts as an advertising proxy that's also doing SRP. Because you could be doing SRP to just a regular authoritative DNS server. It doesn't have to be an advertising proxy. And so that actually wound up, like, it's still basically talking about the advertising proxy, but there's a bunch of stuff in there that's, you know, you could argue isn't an advertising proxy. You know, there's the SRP registrar function basically is an authoritative DNS server. When you're doing an advertising proxy in a stub networks context, it might be bidirectional and you might have different things on one side than on the other. And so, you know, on the stub network side, you might need a discovery proxy serving information about the infrastructure network side. For those of you that don't know about stub networks, that's what the SnackBoff was about earlier. And since I don't think we're going to go to working group last call on this, I'm not going to go into detail on that, but if you want more details about that, you can ping me on the mailing list. And I suspect we'll wind up discussing this on the mailing list. So discovery.
Might I suggest, if you want more detail, read the draft.
That too, but.
And tell us, and if there's anything unclear, ask on the list,
Yeah,
because Ted will answer the questions and also improve the document. So
Right.
I think that's a great way to make sure we publish good documents.
Yeah, yeah. I mean, absolutely, you know, we have to, people do need to read this document to see what, you know, to find bugs in it. But I can help point you in the direction of other documents you should read. Although, actually, if you don't see the pointer in the draft, then maybe it needs to be there. So anyway, the other thing is if it's acting as a discovery proxy and it's acting as an authoritative server for the stub network, it may also need to be a full service resolver for the stub network. So then the question is, like, have we just stopped talking about the advertising proxy and really we need a separate draft for this, or does it make sense actually to talk about all of these functions in this draft? So that's a question the working group needs to answer. I kind of think it makes sense to talk about the whole system in one draft, but you know, that's my opinion. So I don't want to assume that I'm correct. That's just how it looks to me. So that's the basic status. And you know, I think the document is fairly mature, but as we discussed earlier, it probably needs a bit more work and definitely needs more reading.
Thanks. Could we have some volunteers, either in the room or remote, to say they'll read the draft and send comments? Your comments could also be just, looks great to me, but we'd love to get more folks to read it. Anyone like to volunteer to read this document? Thank you, Jonathan. Hui. Stuart, if you could put that in the minutes. Anyone else? Let me check the chat.
Joey?
Oh, Joey as well. Thanks. Awesome. No, thank you. That's very helpful. And I see our AD in the queue.
Yeah, Eric Vink. Quick question, quick suggestions. I like the idea to keep the discovery proxy and the full service resolver in the same document, but I would suggest to change the title.
Yeah,
then
I think that's coming if we do that.
Yeah. Okay. Perfect.
Yeah.
And then my intention was to bundle those three documents in the same cluster before the IHG evaluation, so to keep them together, because it's way easier to progress all together.
Yeah.
Now, if it's delaying everything 6 months or 1 year, then that's maybe not a good idea. So at some point of time, I think the authors, the working group, and the chair, we need to understand how to proceed. Those three together, because it's way easier for the rest, or separately.
Yep, that makes sense. I think it absolutely makes sense to progress them together if we can. Hopefully we don't need to make too many more changes. We did a pretty, I mean, I tried to do a pretty thorough update, but obviously one person writing an update doesn't mean that everybody's going to understand what I wrote or agree that it's the right thing. So hopefully that won't take too long.
Awesome. Okay, that sounds like a good plan, and we'll see based on the how the review looks if we think
Yep.
we're in a place to move them forward.
Yep.
Not too long after the other ones.
Okay, next slide. Okay, so SRP replication, this is not a working group document. I'm just telling you guys about it because I think it should be a working group document. We now have two implementations. The OpenThread has an implementation, Apple has an implementation. We have not done any interop testing, and I know for a fact that the implementations are currently not interoperable. That's because the OpenThread implementation did a bunch of new stuff that the Apple implementation has not yet tracked. So there was an update to how replication servers discover each other. This has been, this is, by the way, there's been a criticism of like this being the TED show. I just want to be clear that all of the updates to the latest document were actually from Upton and Jonathan. So, so Upton and Jonathan are both at Google and both work on OpenThread. This document, I think, is actually fairly mature. It's a fairly complicated thing that it's doing. I think it's a really interesting thing that it's doing. And hopefully there's, I mean, general interest in it. I'd like to see the working group adopt it. You know, I think it's ready to adopt at this point. Whether the working group is ready to adopt it is another question, but it's in pretty good shape.
Yeah, I think we're pretty close. Our thing, we discussed this among the chairs, and what we were thinking is the two documents that we're going to start the working group last call for, as soon as those, like the working group last call is successful and we send them to the IESG, then we'll start the adoption. That way we keep the amount of work in the working group not too high. But on that note, if anyone has concerns on this document and would think that adoption would not be the right thing to do, you have some time here to come and say why, because we'd love to hear that. Of course, there'll be a formal adoption call maybe in a few weeks on the list where people can also phrase concerns, but just wanted to make use of our in-person time in case someone has concerns.
Okay, thanks. Not seeing anybody come up. Next slide. Okay, so I can't remember if I presented this at the last meeting. This was definitely, I think we did. So this is a document that talks about a kind of an edge case that becomes a problem when you have more than one advertising proxy acting as an SRP server, and they are for some reason not in sync, and there are a couple of reasons why they might not be in sync. The normal behavior of an MDNS responder that has authority for a particular name is that it's going to go out and try and see if there's any other MDNS responder out there that has authority for that name using a probe. And if it gets a reply back with an answer with data in it that conflicts with the data that it has, then it's going to tell whoever told it to advertise that data. You know, it could be a server, it could just be a program that's doing that. But in either case, basically it's going to report back a name conflict. And so the idea is first come, first serve. Whoever advertises in MDNS a particular name first gets it. Somebody else comes along, tries to advertise the same name, they lose. And that makes total sense when you've got like a printer coming onto your network and it's got a particular name and you want it to always be advertising that name. You don't want some other printer to come along and get the same name and confuse you. However, we've been doing some fun new stuff in the Dnssd working group over the last few years, and one of the things we've been doing is SRP and advertising proxies. And an advertising proxy basically, so SRP updates a DNS authoritative zone, notionally at least, and an advertising proxy reflects the contents of that zone to a particular network link or links using MDNS. The problem with that is if you've got two advertising proxies, both of which can, in principle, receive SRP updates from the same SRP, what's the word? Requester, thank you. It's new terminology to me. So if you, if you have two SRP, one SRP client, two SRP servers, there are situations where an SRP requester might have registered with a particular SRP registrar, and then it's unable to re-register with that registrar when some information changes prior to the lease on that information on the original server expiring. So we use the lease on the server to expire stale data, but sometimes the data needs to be refreshed before it's stale. In fact, frequently when there's an event like in a thread network, for example, we use SRP, and thread networks are self-organizing mesh networks, and you can have some kind of thing like somebody closes a door and suddenly the mesh can no longer see, like it's been divided into two meshes and each one of them has a different SRP server. Now you have a client that might have registered with the SRP server that's on the other mesh that it's not on. So it's going to re-register with the SRP server, SRP registrar that's on the mesh that it's on, and that SRP registrar is going to get new data, and we want the new data to win. So remember, this is with MDNS we have first come first served, so that means that the old data is going to win, which is exactly what we don't want in this particular case. And so the time since received spec is basically defining a new EDNS 0 option, or actually it's a new it's a new DNS RR type that's MDNS specific. It's not really intended for use with DNS. But this new RR type allows us to say when in seconds in the past we received the registration for the particular information that we're advertising over MDNS in our MDNS probe. And so if another server is also doing TSR, then it's going to get the probe, it's going to look at its time since registration, like when it received the registration, and notice that its registration is older. And because the TSR is there, it knows that we're not doing first come, first serve, we're doing freshest data wins. And so it's going to relinquish its hold on its old data, and now the new registration is going to take over. So that's kind of the primary motivation. There are also some other edge cases with SRP replication where you can have a momentary conflict that you'd rather come out with the new registration winning. Their SRP replication will ultimately clean things up, but you'd rather not have to deal with that. So this is a document that I think is pretty important for the SRP plus advertising proxy situation, and I'd like to see the working group adopt it. It's pretty simple. That said, when we did our initial implementation, we got it completely wrong. And so fortunately, Stuart sorted us out and we managed to get it to work. So that's why the document's been updated. So.
Thanks. So similar to the other document, we'll be waiting a little bit until we get the other ones out the door. And then what would be really nice if we got, so we haven't, I see you have a co-author from Apple, which is awesome. And it would be great if we had someone maybe interested in another implementation as well. We're talking on minimizing it being the TED show. So maybe, we don't have time, we don't have to make an absolute determination, but if you can try to find someone else as well who's willing to help, who's maybe from a different affiliation, I think that would probably make the document stronger.
Cool.
But otherwise, if anyone thinks this is interesting and wants to learn about how writing RFCs is, this is a great opportunity for you. And you don't have to be an expert to write an RFC. Like none of us were when we wrote our first one.
Right. Yeah, and also you have experts on hand, so you can get advice from them. And you also don't necessarily even have to be an expert on the protocol. The main thing is, like, people make comments, somebody's got to update the document, and you might have a discussion with the authors who are experts on the protocol to figure out whether what the person says is sensible and how to address it. But it doesn't have to be that, like, the person updating the document is like the super protocol expert who's done an implementation.
Yeah. So if you're interested, reach out either in person after the session or by email to the current authors or to the chairs, whatever you prefer.
Okay, so that's all of the document updates.
Yep. If anyone has any questions about this documents or comments, this is also the time. Otherwise, we're going to switch to the next set of slides. All right.
So, by the way, that document about discovering DNS servers is actually
the one that expired.
the one that expired is actually germane to the next discussion.
Oh, perfect.
Yeah. So. So these slides are basically here for the purposes of discussion or just presenting the problem, depending on what happens. If nobody's interested in discussing this, then nobody's going to come up to the mic, and I'm just going to breeze right through these slides, and I'll explain them in some detail, and hopefully that will be useful to people who are listening, and you'll get some ideas and come back on the mailing list. But definitely, like if you have something to contribute, or some questions or whatever in the middle of this presentation, don't wait until the end of the presentation, come right up. It doesn't matter if we get through to the end of this presentation or not. The whole point of having this presentation is to have a discussion about making unicast Dnssd real. So let's go to the first slide. So state of the art, we already have manual unicast Dnssd. You can update a zone file, and if you do, like if the IETF has a zone file, and if you do a dig, then you'll get back, I'm assuming you know a little bit of Dnssd terminology. So if you dig for an IP printer at meeting.ietf.org, you get back a couple of pointer records, and if you dig down into those, you get the SRV records, and you get the text records, and so forth, and you'll be able to print. So if you have pretty much any commercial operating system and also Linux, it will be able to discover these printers and print on them. Cups will find these automatically if you have cups installed. And then also we have
Ted?
this. Sorry,
Stuart Chess from Apple. Probably most of the people in the room know this, but I just want to check it because there might be some who don't. The reason Ted is showing this is not because we expect anybody to be typing dig commands.
right.
If you're on your iPhone and you press the share button on a web page and go to print, you will see that IETF 114 printer shows up and is an available printer.
Right.
And that's because your iPhone is doing this query to ask this network, are there any printers I can use? So that's maybe that's obvious to everybody, but I just wanted to make sure.
Yeah, the reason I put the guts up on the slide is actually because there could be some DNS people who don't know Dnssd that well, and I want to just give them a little view of the guts of the protocol. But yeah, that's absolutely right. This is all done automatically. You never want to actually have to type this stuff in. So anyway, moving on to the second piece of state of the art, and this is something that if you buy like an Apple HomePod Mini or Apple TV, and I suspect there are other devices that do this, but I don't know the details. Like this was me actually doing a dig at my Apple TV using MDNS to discover the Apple TV, and then look up in default.service.arpa, which is a domain that we happen to support for doing this kind of lookup, any printers, and it did an MDNS query, and it responded with a record with a TTL of 10 that pointed to my Brother laser printer at home. So that was all done automatically. That exists. You can buy things that do that. We have an RFC that describes that. It's really cool. And then we also have SRP updating a DNS authoritative server. Again, like if you have any sort of thread border router, including an Apple TV or a Mac Mini, the latest ones, they support SRP updates, and they support the advertising proxy. Of course, the advertising proxy isn't really unicast, but I mention it because SRP is. Just to give you an idea of what building blocks we have already built, what we already have available to use. This is all in open source code, so it's not like it's just an Apple proprietary thing. I think that OpenThread has implementations of most or all of this stuff. Yeah. Jonathan knows everything about OpenThread. So next slide.
Do you mind me jumping up and
Not at
interjecting?
all.
Let's go back to that slide because I think Ted sort of glossed over like a minor miracle happened, and it might be, it's the kind of thing that would be good to explain with a picture. So where Ted shows that dig command office.local under discovery proxy, I just want to say a couple of sentences about more of what's going on there. Traditionally today on most of our home networks, devices that are using multicast DNS are multicasting the whole network. And we know that multicast on Wi-Fi is slow and unreliable and wasteful of spectrum. And when you had 2 or 3 devices on a typical home network, that wasn't a big deal. Now, if I add up all my HomeKit devices and the garden sprinkler controller and the solar panel inverters, there's more than 100 Wi-Fi devices on my network. And when my iPhone is looking for printers, it multicasts every device, saying, "Are you a printer?" And all the light switches like, "No, I'm still a light switch. Stop asking me." So what Ted did with that command was, instead of multicasting the whole network, he sent a unicast to, in this case, his HomePod, and said, "Look, you probably have a cache that's up to date. Can you just tell me if there are any printers without bothering everybody?" And if the HomePod doesn't know, it's going to multicast on your behalf. But if somebody else asked the same question 2 seconds ago, you don't have to spam the whole network with another multicast. The HomePod can just say, "Yeah, here's the answers." And so this is the first step in the direction of trying to make a lot less use of multicast on our home networks and move more of it to unicast.
Yeah. I'll say 2 things that Stuart was polite enough not to say. One is, Ted, you forgot the motivating slide, which I did. Oops, sorry. And 2 is, MDNS is actually really smart. Like, it's insanely smart. It does all this cool stuff to avoid multicasting if it doesn't have to. And so every MDNS responder that you have sitting on your network, and every Apple device you have, every Android phone you have, every Windows machine you have is doing this all the time. They sit there and they listen for MDNS packets, and they're just passively snooping on the network all the time. And they're building a little cache that contains all of the information about all of the services that they've seen advertised on the network. If anybody ever asks whether there's a service present, all of the other devices that are on the network get that multicast and add the service to their cache. This, by the way, explains why MDNS is sometimes flaky. If you have a network that filters out multicast packets, then the cache building algorithm may make a mistake because, you know, somebody sent out a query, it didn't see any responses in it, so it assumes there aren't any. It assumes that it also wouldn't get an answer if it sends out a query. And so, you know, if you have something that's suppressing multicast, then you can wind up with an incomplete cache and negative responses when you should have gotten positive responses. So the discovery proxy is actually a really useful piece of technology because it takes out all of these MDNS responders sitting around doing, anybody can talk to a discovery proxy and get the same exact behavior as if they were talking to, as if they were doing MDNS themselves, except that they're not doing all of that multicast snooping and they're not doing all of that multicast broadcasting. They're just, you know, they just send a unicast to the discovery proxy and the discovery proxy takes care of it for them. So, so the motivation with unicast bonjour is, in a sense, to get rid of multicast on every link, or at least every link where we care about getting rid of multicast, and that means every Wi-Fi link, because Wi-Fi is not great with multicast. If you have a Wi-Fi mesh, it's hard to get multicast to work well on a Wi-Fi mesh for, you know, complicated but probably fairly obvious reasons. And so being able to do unicast instead of multicast in the same context and get the same results is a pretty clear win. And so the question is, can we do it? And so the point of this slide is to talk about what pieces of it we've already done. Let's now go on to the next slide. So what would it take? We need to be able to find the unicast Dnssd service, right? So thinking about the previous slide, I just happen to know that office.local has a unicast Dnssd service. So I did a dig pointed at that and I got my answer. How did I know that? Because I just happen to know that all Apple TVs have that, and I happen to know that that was the name of my Apple TV, and so I could type it in. Obviously, that's not going to do it. That's not automatic. What's that? Yeah, and I wrote it. Sorry.
Yeah, step 1 for using this, get a job at Apple.
Yeah, I know so much more about Dnssd than I did before I started at Apple. It's very exciting. So we need to be able to discover the Dnssd service. We also need to be able, remember, we want to do unicast in both directions, right? We don't want to just do unicast for discovering services because that's not as good as doing unicast for also advertising services. So we need to be able to discover the availability of an SRP registrar on our local network. And I don't know why I said as above. Oh, discoverable. No, I still don't know why I said as above. I know I had a reason. I just don't remember what it was. So it's an authoritative DNS server that is being maintained by SRP. We need a discovery proxy because Stuart knows why I said as above.
I think I know what you're trying to say. This is like two sides of a coin.
Yeah.
We have clients that are looking for services, want to discover a discovery proxy that can do that on their behalf, and that eliminates one side of the multicast. Devices that want to offer services on the network want to be able to discover a registry that they can register with. And those sound like very similar things, and they are very similar things, but one is a client looking for services, and the other is services seeking to offer their services, make them visible to clients.
Right.
So I think that's what you meant by.
Yep. Yeah. So, and we need to, let's see. So yeah, we need to bear in mind that there are going to be devices on the network that don't know how to do SRP, right? So like, maybe I'm going to cram SRP registration into some future version of some, operating system. But I can't assume that my brother printer is going to ever get a software update to do that. So I'm still going to need to be able to do MDNS to discover my brother printer. Hopefully future brother printers will fix this, and maybe I'll get a firmware update, but I can't count on it. So we have to have a discovery proxy to just get us the legacy clients, the legacy services, I should say. We need a full service resolver. The reason first, full service resolver, what it gives us is that when we get a query for stuff on the local link, the full service resolver, on port 53 or whatever, the full service resolver knows, oh, I need to go into this database to get that information, not just forward it to my ISP. And the other thing is, so we have all of these devices that are consuming this service, but what if the service goes away? We may not need this. It depends on how we're doing the service. If the service is provided by the network, like by your home router, well, when the home router goes away, okay, you're not going to be able to do MDNS, but your home router went away, you don't have Wi-Fi, it's not going to matter that much. When it comes back, you'll have it again. So we don't need to solve that problem. But suppose that, for example, we decide that because home routers don't currently offer this functionality, maybe we want to offer this functionality that you can discover through MDNS, right? You discover, the replacement for MDNS using MDNS, and then you can stop using MDNS until it goes away. Well, okay, so if it goes away, then we need to fall back to MDNS. That's the point. Next slide. So, and then another thing to think about, and this is actually a hard problem, is how we address the various ways we could deploy this. So a typical way to deploy it would be that you've got a single link in your home network, and you just need to be able to do what you're already doing, right? Right now, you can already discover your printer on your home network. You only have one link. We just want to replicate that same functionality. Another use case is where you have pretty much the same setup, except you have some stub networks, like you have some thread border routers or whatever that are connected to your home network, and you'd like to be able to discover the services that are being advertised by hosts on the thread network, as well as the services that are being advertised on the Wi-Fi network. You might have a multi-link network that's somewhat managed, like a Soho network or even an enterprise network. And then, so that's like what the network looks like. And then there's the question of what the service offering looks like. So the service I'm talking about here is the Unicast Dnssd service. So that service might be part of the infrastructure. It could be something that comes on your home router. It could be something that doesn't come on your home router. If it doesn't come on your home router, then maybe we want to offer it using MDNS, as I said earlier. It could also be managed by, like, an IT staff, right? So there are a lot of ways this could happen. So my point in putting up the slide is not to say what the deployment models are, but just to talk about the deployment model problem so that we think about that. Next slide. And then there's like the naming model. So you know, the naming model for multicast DNS is really simple. Everything ends in .local, right? You can advertise names that don't end in .local in MDNS. It's not forbidden, and in fact, I've used that functionality. Joey wrote some code that uses that functionality. So it does work, but generally speaking, when you're doing service discovery with MDNS, you're using .local. So one naming model we could use is to just replicate that. Like, you know, if you say .local, then we do unicast Dnssd to do the resolution for whatever's in .local, and .local just means the network link that I found this service on, right? So, you know, you might have several network links, and each of those network links with multicast DNS is its own little .local. Those network links can actually have conflicting information on them, which is a bit of a problem. And there's no way to resolve that because the links aren't connected to each other. So there are problems with using .local that way, but you can use .local that way as long as you're willing to accept those failure modes. And one nice thing about using .local is if your DNS, you know, all singing, all dancing, unicast Dnssd discovery service goes away, then you don't need to use a different name when you're using MDNS. So there's an advantage there. Again, I'm not saying what we should do. I'm just describing some of the issues and some of the ways we could think about this. So another approach, which we actually have been talking about more when we were doing the HomeNet stuff, we talked about this, and I think the Discovery Broker document that Stuart did a while ago, which is expired, talks about this. And also the document that expired that we were talking about earlier talks about this. And that is just give every link a global name. So every link has a name that is unique to that link. And whenever you want to discover services on that link, you use that name. And so, you know, Dnssd has this concept of a legacy browsing domain, and that's a list of a legacy browsing domain list, and that's a list of domains that you sort of by default, you know, in your legacy behavior, which we never actually figured out what the non-legacy behavior was. So legacy behavior is the current behavior. You just do service discovery. If you get a question like, give me the list of all printers, and it doesn't specify a domain, then the legacy browsing domain is what you use to iterate across the set of domains on which you're going to do that service discovery. So, so we could do that, and we could, the legacy browsing domain on any given link could be a list of all of the per link names that are present in the local infrastructure, right? That's one way to solve this. These aren't necessarily mutually exclusive either, right? You could say, you know, whenever you do a .local query, that means the link that you're attached to, but you're also allowed to do, you know, you could do the same query by specifying the link, the global name for that link, and you would get the same list of answers. So that's another approach. So again, I'm not prescribing anything. I'm just saying, like, here are the naming models that we've been talking about, and we need to figure out if we're going to do unicast Dnssd, we need to figure out how we're going to approach this. We may come up with an approach that says, you know, in the most simple case, we do .local, but we need to have this perlink naming thing in our back pocket for the more complicated cases. Or you may say, you know, we really should do perlink naming because, gosh, that really solves the name conflict problem nicely, right? So anyway, those are some topics. Next slide. I don't know if we've run out. Oh, obstacles. Yeah. So yeah, one issue, I was talking about legacy browsing domains. One issue is the legacy browsing domain only works currently, at least on Apple platforms. I don't know if this is true of other platforms, if you don't specify a domain to do service discovery in. Right? You just you pass null in for the domain, and then it uses the legacy browsing domain list as the list of domains to do queries in. A lot of people pass .local, and so do we need to override that? We have to kind of answer that question when we're thinking about the domain naming or the link naming problem. You know, if you do, there are advantages to doing perlink naming as opposed to using .local. If you do perlink naming, then the name of a device doesn't change depending on where you are. If you don't do perlink naming, or if you do perlink naming and do .local, then if a device was discovered using .local, then it also has this other name, which you could potentially use to talk to the device, but you're not going to because you know the device by its .local name, which is not valid everywhere. Is that a problem? I don't know if that's a problem. It's just a thing to think about. Oh, we have a question. Subir.
Thanks, Ted. My name is Subir Das. I just want to ask you a basic question. When you say link, right, is it a, and also you have an example of Wi-Fi, right? So is it the link means an IP link or is it a Wi-Fi layer link, like a layer 2 link?
Yeah, so I'm using Wi-Fi as a shorthand. That's a good question.
Okay.
Using Wi-Fi as a shorthand for the infrastructure link, which might be a link that's bridged between Ethernet and Wi-Fi, or it might be Wi-Fi only, or it might be Ethernet
Okay.
only.
Okay.
It doesn't really matter. I just used Wi-Fi as sort of, because Wi-Fi is the usual
Right,
link.
right. Yeah, also the reason I'm asking is that possibly you and Stuart know that in Wi-Fi, new evolution happening with multi-link device, right? So today, if I have a one radio in one link, that means I have a full stack to the IP on that particular link,
Yep.
even in the layer 2. So what is coming in future is that multiple links, layer 2, will represent that one interface to the IP. So that means I can have two links, right, with my device, and I'm operating, but I'm connecting with one IP link to the router to the backend, right? So I can then, if I send a query, right, I can actually send only one link, not the all links, right? So I'm just trying to understand that scenario, that when the query goes, will the query go to every Wi-Fi link, or the query only go, only one link to the network?
Right. I think Stuart has an answer for that. I'll just say, for my own opinion, that's a question we need to answer.
What I was actually going to say is I'm not actually aware of what you're talking about with these new developments in Wi-Fi. So thank you for coming up to the microphone to make us aware of that. And we're kind of out of time now, but we should definitely talk more and learn about that.
Yes, yes. So yeah, just to give, since I'm also involved there. So next generation Wi-Fi, which is Wi-Fi 7, which will come in 24, right? That's the market we are looking at. I think what is happening in IEEE is that a device can have multiple links, both for the endpoints and the DP, and then it will only open up one interface to the IP, and that would hide the multiple lower links.
It's interesting because the use case that I actually care about is the exact opposite of the one you just described.
Yeah.
I want to be able to connect to multiple SSIDs using a single radio.
Right. So one thing also, we all know that, in our IEEE terms, they don't talk about SSID, right? That's the deployment model, right?
Yeah.
So that is, of course, something will evolve and how those are configured, right? But the way that things are evolving is that there is no visibility for the IP that is underlying the multiple links are. And also it is allowed that device can have one at a time, say 2 or 3 links, but it can decide or operate only one link, at a given time. But it can have at least 2 links, and that's the way it is evolving.
Well, I certainly look forward to seeing this stuff when it's available to look at. That sounds very cool.
Wait for Wi-Fi 7.
Yeah, thank you. Cool.
Thanks, Subir.
Yeah.
Dave? And I think we're going to cut the queue after Dave because we're almost
Yeah,
at
I
time.
was doing this because I just figured you were about to do that. I'm going to take advantage of having been a note taker to continue Subir's theme of expanding use cases. MDNS is starting to get adopted in the parallel universe called storage. The NVMe over Fabrics is the successor to iSCSI as a network storage protocol. NVMe OF is not an IETF protocol, but it's using MDNS to solve a discovery problem. It's going to be doing it in exactly the enterprise networks and the big ones where you don't dare let the multicast domain scale over even a small portion of the network. And so it's headed right for the problems this working group is taking up. This is another place to go looking for people who might be very interested in implementation.
Can you, you actually know those people, it sounds like.
I got to be careful because one of the things that gets in my way here is that NVMe protocol development work is done under an NDA, so I have to have discussions like that with someone whose company is under the same NDA, and I apologize for that difficulty.
Totally understand. The reason I mentioned it is because it might be possible for you to tell them to talk to me so that they don't have to tell me anything about NVMe. They just need to tell me about what they need from me.
We'll have to look at the details here. Unfortunately, storage is different enough from a printer that you will need to understand why the problem is different.
Okay. Well, we might also be under the NDA. I don't know. Anyway, let's see. Did we cover everything? Yeah. Okay. Yeah, I think we pretty much covered. So basically, you guys now understand the problem.
All right. Well, thanks so much for all the presentations, Ted. Thanks so much for everyone who participated. That was some interesting information that we didn't know. That's really helpful. And thanks to our note takers, Stuart and Dave, and I guess to our Jaggerverse scribe, me. You're welcome. And thanks everyone for coming. Happy rest of your IETF week, and we will see you on the mailing list, I hope. We'd love to get as much review of the documents as possible. Anytime. 10 no's.